Sure do wish I had a collet chuck. They're so expensive though. Huh. I wonder. Hello Internet, my name is Quinn and this is Blondihacks. Since around the Neolithic era, I've wanted a collet chuck really badly, but I've never had the means to acquire one. Now, there's this thing called electronic bay. It's pretty new, you probably haven't heard of it, but I'm plugged into this kind of thing, so allow me to explain. On this eBay, as we in the biz call it, people sell all kinds of crap. Some of that crap comes straight from China, and a lot of it is, let's say, collet chuck adjacent. Now, a very generous viewer sent me a very nice package of these types of parts from eBay, and I want to see if I can make a full-blown collet chuck out of it. So let's go. We're going to need some long steel for this, so it's over to the junk annex. I think this chunk of 12L14 will get the job done here. Yeah, it's looking good. Now, I'm going to need to know how deep the spindle bore is on my lathe. So using the highly precise machinist's tape measure here, I can cut a chunk of this off, and this will all make sense here in a moment. But over to the horizontal bandsaw to get it down to a more manageable size. And Yahtzee right into the tripod. This bar is going to be attached to my future collet chuck, and it's going to be spinning very fast, and I don't want it to vibrate, so I'm going to turn it between centers. So I'm dialing it in the forejaw, and I'm going to face off the end. I'll just deburr that, and I'll punch a nice center in there with my trusty number 2 center drill. And then I'll flip it around, do the same thing on the other end. Now I can pull the forejaw chuck off, clean out that bore, make sure the taper's nice and clean, get my live center in the headstock end there, get the bar in there, and we are ready to turn between centers. So a generous viewer sent me this kit the other day, and you can get these on eBay straight from China. They're pretty affordable. And what it is an ER32 collet closer on a Morse taper 4, and it's got a drawbar thread in the back. So what it's really intended for is tool holding in Morse taper mills. However, I have a Morse taper 4 spindle in my lathe, so I think we might be able to convert this into a collet chuck. There's basically two kinds of collet chucks. There's ones that go in the spindle bore on the lathe, and then there's ones that sit out in front of the spindle bore. The reason is simple. If your collet has to go inside the spindle bore, then you're limited by the size of that bore as far as what kind of collets you can use. So in a small lathe like this, I've only got, I think, a 1 1/8 inch bore in this lathe, so 5C collets, which would be typical for a collet chuck, are too big to go in there. So pretty much any kind of in-bore collet chuck is going to be off the table unless you use very small collets like 3C collets or decal collets, something like that. Now you can buy 5C collet chucks that are entirely self-contained out in front of the spindle nose and hold the collet out here, and then you just have to make a backer plate to fit whatever the mounting system that your lathe uses. So enter the ER collet. Now these things come in a couple of different standard sizes. This is an ER32. You might also see ER16s, which are the really small ones, or the ER40s, which are the larger ones. And what's nice about these is that they are a lot shorter than 5C collets. So you can have them held out here in front of the spindle nose, and they're quite a bit more rigid and more precise because, again, they're closer to the nose on the lathe. There's two other things that make ER collets really appealing for a collet chuck. The first is that they are front closing. So the collet is closed up by a nut that goes on the front and applies the force on this little taper here on the front of the collet. Most other types of collets, such as the 5C, have threads in the back, and the collet is expected to be drawn into a taper to close it up. And what that means is that you need some kind of a drawbar or a draw tube to close that collet. You can't close it from the front, you have to close it from the back. And then the other big win for ER collets is that they are a double split collet. So you can see that there are split lines that start at each end. And what that means is that the collet closes more or less parallel compared to a single split collet like the 5C, where the jaws close with a single hinge point at the base. And what that means is that 5C collets are very, very sensitive to the size of the work. You have to be within just a few thousandths of the size of the collet in order to hold work properly. If you try to over or under stretch the collet, then you're just pinching the work at the end. The back end is unsupported and it becomes unstable and you damage the collet as well. So ER collets are a lot more forgiving for not having the exact size radius, which is great for work holding in a collet chuck where you're not always going to have a very precise size. Now both these collets are through collets, which means you can put work all the way through them, which makes them good candidates for work holding. Contrast that with an R8 collet, which is good for tool holding in the mill. It has a drawbar thread in the back, and thus you can't thread work all the way through the collet. So you're limited in what you can hold by about this length here. So enter our friend the eBay Morse Taper ER collet closer. This thing can go in my spindle, and I can close an ER collet in it from the front, which again, very handy, and ER collets, very handy, and I can use it as, I think, a makeshift collet chuck. Now the only issue really is that, again, this is intended for a mill, not really for work holding, so it has a drawbar thread in the back, and it's intended to be pulled inwards with a drawbar just like on a mill. Compared to something like a 5C collet chuck, which would use a draw tube that will take up some space in your spindle bore, but still allow you to pass work all the way through to the back wherever your closer is. Now you could potentially use this without a drawbar, just using the friction of the taper. I'm not crazy about that idea because if the machining forces get too high, you could cause this taper to slip or even pop loose, so I would rather not run it that way. So I am going to make a drawbar that goes through the spindle bore and tightens on the back of the headstock. That does mean, of course, I'll lose the ability to pass long work all the way through it, but this thing is pretty long, so I'll still get that much length out of it. And for working on small parts, which is mostly what I want this for, I think that'll be fine. And hey, considering this costs a fraction of what a real collet chuck does, I think it's worth a try. By the way, you may have noticed that for almost the same money as these parts, you can also get full-blown 5C collet chucks on eBay direct from China. Are these things any good? Well, as luck would have it, my friend James over at Clow42 just bought one of these, put it on his lathe, and did a deep dive on it. So go check out his video. I'll put a link down in the description. I'm making the drawbar, as you may have surmised, so it's time to figure out what this thread is. I can check the minimum diameter there, which gives me a ballpark, so we're somewhere in the 5/8 inch range here. And I tried to get in there with my thread pitch gauge to try and figure it out, but it was just too hard to see. I couldn't tell what was going on in there. So instead, I got out some Prussian blue and I smeared it around in there. And then I stuck a piece of scrap in there and made an impression on the scrap. And luckily this is a coarse enough thread that this gave me a sufficiently precise impression that I could measure it. It's a little bit sloppy, but it's close enough for this job. Unfortunately, my cheap thread pitch gauge only goes down to 12 threads per inch, and I could tell this was coarser than that. So I had to go older school, and I just measured a fixed length and counted the number of threads in that distance. And luckily with a really coarse thread like this, that's pretty easy to do, and it seemed like it was 11 threads per inch. So I did some Googling and determined that yes, 5/8 11 is quite a common drawbar thread in a Morse Taper 4. So that seems to be what I have. All right, let's make some chips on the drawbar, turning between centers. Start with a light cut, get the feel for things, and oh my, we are deep in Chattertown. So I did a few checks, make sure everything is tight, all the basic stuff, everything looks good. Lighter cut, still no good. I can't even touch this part without it chattering. I tried a bunch of different settings, feeds and speeds, the works, checked everything is tight, just could not prevent this chatter. So it must be just the length of the bar. So one old school trick you can do to absorb harmonics in a case like this is wrap some leather around the part. And that did help. I could do a couple of thou depth of cut before the chatter kicked in. Wasn't really good enough though, so another old school trick, you can wrap some lead around there. That helped more. I could do about a 5 thou depth of cut, but still not good enough for what I want to do. So it was time to get serious, and I brought in the follow rest. Now this is not ideal because it means the follow rest is going to be riding on an unmachined surface, so it's not going to be perfectly round, but we'll give it a shot and see if it helps. So I have the steady rest set a little bit looser than you would normally do because, again, the surface isn't totally round, but this actually helped a lot. So I was able to get a 10 thou depth of cut here, and if you listen carefully, you can actually hear the chatter start, and then it gets killed again by the follow rest, and it starts and gets killed again. So we're right on the edge here, but the follow rest is doing its job. But we got a nice clean starting cut all the way down. And then I went in as close to the lathe dog there as I dared. Now this worked okay, but I wasn't super happy with it, so instead I brought in the steady rest, and now I've got lots of rigidity. I can take full depth cuts now. The disadvantage to this is I have to work on the bar in sections. I was hoping the follow rest would work because it meant I could do the whole bar in one setup. So why turn this between centers, you might be wondering? Well, a lot of reasons. First and foremost, turning between centers is how you get maximum concentricity. So for a shaft that's going to be spinning at high speed, that's really advantageous. When you turn between centers, there's only 2 points that are referencing the shaft to the machine. So it's how you get the most precision on the roundness of that final part. Second of all, when turning between centers, you can pull the part out and put it back and even reverse it end for end and never lose that concentricity. Again, because you're only referencing it to the machine by those 2 points. So all of those features make it a great candidate for this particular part. Next, I'm going to cut the threads at this end that thread into the back of the collet closer. So I'm going to reduce this diameter down to 5/8 because you recall I'm going to need a 5/8 11 thread on here. Then I'll put a generous chamfer on the end, which looks nice and helps the thread start easily. And I'm going to put a thread groove up at the base of the thread, which give me a place to start with the thread cutting tool, and also adds to the strength of that connection there because it gives it a round profile right in that groove there where there might be stress risers. Now I don't own a 5/8 11 die, so I'm going to have to single point cut these threads, which means a lot of change gear gymnastics because this is a low budget hobby lathe that does not have threading gears in the transmission. So swap out for 11 threads per inch, and I'm going to get my threading tool squared up with the fishtail here, and we're ready to go. I gotta say, this setup is pretty fun. I'm single point cutting a thread almost 20 inches away from the spindle. I'm almost at the maximum length of my lathe bed here. I've never cut a part this long before, and it's it's working really well, so I'm pretty pleased with this. I'm within a few thou of where the book says this thread depth should be, so it's time to stop and do a test fit. And it threads on there, but it's a little snug, and it gets tighter as it gets to the base, so we're not quite there yet. Now, before doing another cut, I always like to do a little deburr on the crests of the threads. The file is facing backwards because the lathe's running backwards because I'm threading away from the chuck, but it's always a good idea to do that and check it again before doing a final pass, just so you don't cut the threads too deep by accident. One more spring pass without actually even dialing in any more depth, and that threaded right on there perfectly. So I'm very happy with that. Seats up firmly on the shoulder of that collet closer there. I almost had to remove my tailstock to do these test fits without upsetting the setup, but luckily there was just enough room, and the steady rest holds it in place. Speaking of that steady rest, I can now move it down and work on the next section here in the middle, which just needs to be turned down to match the first part. This is one of those things that when I was first learning machining, I thought would be really difficult. You know, machining a second diameter to match one that you've already turned because you've gone and moved all the dials and everything's going to be, you know, you'll never get it quite exactly where it was. But actually, that turns out to be pretty easy to do, much easier than I thought. If you turn the cross slide in back into that same number, it'll be within a few tenths of where the previous cut was. And usually that's enough to where you can't feel the transition or see it once it's cleaned up even. And then you can always just polish the whole shaft at the end to even it out a little bit if you need to. Now before I work on the other end, I want to do a test fit here in the spindle, so I'm going to thread it into the back of the collet closer, and this will allow me to take some measurements with the real deal before I proceed. I don't have a drawing or anything for this, I'm just making it up as I go along, so I want enough room for the wrench there on the end, and that looks good, so I can now come back in and set it up with the steady rest and everything on the other end. Unfortunately, the lathe dog has to go where my threads were. I didn't plan that part very well, so I put some copper in there to protect the threads, and I'm just not tightening it down too hard, and that worked fine. So once again, just starting by turning this end down to diameter. And I'm going to cut the threads on this end with a die, but my shaft ended up quite a bit too long, but I didn't want to cut it shorter and lose my original center, because I want the whole shaft to be turned with that same pair of centers, so I ended up just cutting the entire end of that shaft all the way down to 3/8. I chose 3/8/16 because that's the threads that are used on my strap clamp set for my mill, and so that will allow me to use the same nuts and the same wrench on this tool. Okay, 3/8 16. Let's see, 1/4, 5/16, 3/8 24, 7/16, half. Oh, I went too far. 7/16, still 3/8 24, 5/16. So I went too far again. 3/8. Wait, how do I not have a die for one of the most common thread sizes? Standard imperial fist shake. So I'm going to have to single point cut this thread because I apparently don't have one of the most common dies in America. So here's what I'm going to do. I'm going to put a groove at the end of the thread, and this is going to do two things, which I'll cover in a minute. And then I'm also going to cut a round base groove just like I did at the other end. Now that groove on the end is going to give me a run out area for the threading tool, and it's also going to end up being a small boss that I leave on the part, and that's going to give me a place that I can hit this bar with a hammer to pop the collet chuck out without mushrooming the end of my thread. And otherwise, this is just a standard single point cutting routine, just like it did on the other end. I spared you all of the extra change gear swaps that I had to do to set this up. It was a lot of change gear swapping, but I gotta say I'm getting pretty good at that now. Well, I didn't think that through very carefully, did I? I'm at what I think should be the final thread dimension, and I have no way to test it with the nut because the nut won't fit over that shaft on the end. I could turn that whole thing down, but I figured, you know what? I'm pretty confident that I'm on dimension, so I'm just gonna cut it off right here. I didn't fancy my odds with a parting tool here, so I just used a hacksaw. Got a board down there to protect the ways. Test fit with the nut, and it doesn't fit, because of course it doesn't. So I can't turn it in this position because there's nothing holding it in against the center at the headstock end. So I dismantled my turning between centers, put the 4-jaw chuck back in, dialed it in, and I did all of that with extra tooling so that I didn't have to touch my thread cutting setup, which was all still sitting on the carriage, and then I could bring the carriage back in, and really all it needed was a couple of spring passes, and the nut fit on there great. And then I could just face off my hammer and nubbin there, clean up the saw cut, and I did end up actually putting a center in it again because I want to pull it back out and do a little polish on it. So that center is kind of an evil center because it's not perfectly concentric with the original center that was used to turn the entire shaft. So 20 years from now, future Quinn is going to find this, try to use those centers again, and wonder why it's not running true. Anyway, a quick polish to take out the steady rest marks and even out a couple of those transitions. And let's do a test fit here now and see how we're doing. So there's the collet closer in one end. Just tap that in, and I can thread the drawbar into the back. And now I can take measurements for the cap that's going to go in the spindle bore on the end and allow me to tighten the nut against it, which is then going to pull the collet taper inwards. For this cap, kind of a good news, bad news situation. Good news, I found a perfect sized piece of scrap to make this from. Bad news is, it's the last of this really awful mild steel that I never am able to turn very well. I've shown this on my channel lots of times, it's terrible stuff. So I got out the carbide, and it's actually doing pretty well as long as I take a really aggressive feed with it, which, you know, is what carbide generally wants. If I try to take any kind of light cut, finish goes to poop again, and then when I come back in with a really heavy cut, finish is great. This is the catch-22 of carbide on hobby lathes. You really can't push it hard enough to do what the carbide wants to do. I mean, my lathe is doing this, but it's not happy about it. It is making unhappy noises. And then I can't take nice finishing cuts. The finish goes to poop again, and I'm not in deep enough to get to the chip breaker, so the chips aren't breaking. It's a whole thing. So it's back to my high-speed steel and cutting oil to put a little boss on the end here. This is what's going to register inside the spindle bore. Now I can bore this thing out. So I'm going to center drill it, and I'll set up to drill here a pilot down the center. Just got to make sure I drill deep enough to get to the end of my part here. And this is a through hole. This is where the threaded rod goes through, and so I'll widen this up to one size below my reamer size. This reamed dimension fits over that shoulder that I left behind the thread on the back end there. I don't know if you noticed that, but you can see how that fits in there now, just like that. Should be a really close fit, which it is. It slips in, but there's zero play in that, so I'm really happy with that fit. Over to the tailstock now for one of my dirtiest tricks that I'm not proud of. Put a Morse Taper 2 end mill holder in the tailstock. Put an end mill in there, a 2 flute is a good choice, and now I can make a nice flat-bottomed hole that's going to be a good starting point for my boring operation. The secret to this is low RPM and very slow feed. Give that end mill plenty of time to do what it's doing, because it's not a drill. It's really not designed to be plunged this way. But if you go easy on it, it does work, and it leaves an almost flat-bottomed hole. End mills actually have a little bit of a reverse cone in them. It's clearance for when you're end milling the way they're supposed to be used. But it saved me a whole lot of boring time. So now I can come back in with a boring bar and just open this up to final dimension. It's nice to have that flat-ish bottom in there as well because it makes it easier to get to your final dimension with the boring bar as opposed to a drill which leaves a 118-degree cone in the bottom, and then you have to clean out that cone before you can really get in with the boring bar to final dimension. Quick check with the bore gauge here because I should be close. And yep, we are close, so I can do a finishing pass now with that boring bar. And I think that should be it. Let's do a test fit here with the bar going in the correct direction this time. And that slides in there really nice. Again, no play, so very happy with that fit. Everything's coming up millhouse on this project. I'm ready to part this off now, so I'm just lining up the edge of my parting tool with the scale there on the front edge of the part. And then I got my long travel indicator that was a donation to the channel actually, so that I can measure the 1.4 inches down that I need for the total length here. And now I can go in with my parting blade. This was a slow and steady parting operation. This garbage steel does not like being parted, so I had to go real easy, lots and lots of fluid, and eventually managed to get it done. And sorry, no Yahtzee shot on that one because I actually cheated and finished with the hacksaw. But then I faced it off and put a nice generous chamfer on there so that part is comfortable to hold and, well, it looks nice. So that should be it for this part. Let's do a little test fit here for realsies. So that collar slips down over the shaft and it registers on the shoulder behind the thread, but it doesn't sit down on the shoulder on the main part of the shaft. There's a little gap in there, and that's necessary because remember the drawbar is pulling the taper tight at the other end of the bore. And then the cap sits on this end of the bore, and then the drawbar squeezes the two ends together in between. Let's put it all together now. So I'll thread the drawbar into the collet closer. I found it's easier actually to do this first, then thread it through the spindle. Put the cap on the back there, and then put the nut from my strap clamp set on there. I actually needed to face a little more off of this cap. I miscalculated there, so there's a thread short there on the nut, but that's okay. I did fix that later. And now I can tighten that down and spin it up. And, well, seems okay. But the real truth is in the indicator. So I'm going to get out the big guns for this one. I got my 10th indicator here. I'm going to get a baseline on my spindle nose, and we've got between 2 and 3/10 here right on the nose. So that'll give us a starting point. Now on the taper of the collet closer, we're up to about half a thou there, so we've lost a couple tenths. But here on the taper where the collet sits, this is what's really important. And here we've got about 5/6, something like that. So that's not too bad actually. So I'll get a collet in here and let's see what the work is actually going to see. I've got a gauge pin on here, which is the straightest and most well-made thing I own. And here on the gauge pin, we've got somewhere between 7 or 8/10. So we lost another tenth or two in the collet itself. But this is actually not too bad for the price point of these parts. Okay, blah, blah, blah. Does it make chips? Let's find out. Here's some brass. Nice light cut. First chips on this tool and seems to be working great. Let's do a big girl pass. Yeah, look at that. That's a 100 thou pass in brass. No chatter, no trouble at all. That's working really, really well. So it's certainly not short of rigidity. That's good to know. All right, but brass is easy mode. Let's try some tool steel. This is 01 drill rod. A light pass is going just fine, so I worked my way up gently here because this is tool steel, and I was able to work my way up to a 50 thou pass, which is actually pretty good for this lathe on tool steel. That's about as much as I do in my regular chucks anyway, so I'm certainly happy with the rigidity of this thing. We have one last little quality of life problem. I need a way to immobilize this thing so that I can break the drawbar nut loose, and so I need a spanner wrench of some sort. My mill one doesn't fit, unfortunately. I couldn't be that lucky, and it didn't come with one. So I used my mill wrench as a starting point. I traced it onto some hot rolled steel plate here, and I just shrank the size of the opening there a little bit as I traced it. So I roughed it out with an angle grinder because none of my little bandsaws are really up to this job. And I cleaned up all the edges on the mill, and then I used the mill to just kind of freehand close to the scribe line there on the inside. And then I finished that out with some filing. Fortunately, that scrap I used had a grinder nick in it in a really unfortunate place, and I didn't notice it until it was too late. So I just welded that up and then ground that flat just so that that doesn't someday crack. It's kind of in a critical spot right there. And just because I can, I hit the whole thing on the Scotch-Brite wheel. I dubbed the Sparkle Spanner. Alright, one more final assembly because it's fun. Thread the drawbar into the collet closer, thread that assembly through the spindle bore, put the spindle bore cap on the end there, and then put the nut from my strap clamp set on there, and then a wrench on that nut and Sparkle Spanner on the collet closer, tighten that up. and we are ready to turn some parts in my homebrew collet chuck. And then when all is done, I just tap the nub in there on the end with my copper hammer, pop that out, unthread the drawbar, store that in a violin case, and it's ready for use next time. Oh, and that mild garbage steel? Yeah, so long. That's the last of it. There it is, my homebrew collet chuck cobbled together from eBay parts. For finish, I decided to leave everything bright. I just hit it all with some Boeshield T9 corrosion inhibitor, so it'll stay nice and shiny. I think you should try making one of these too if you're looking for a really low budget collet chuck solution for your hobby lathe. This worked out really well. I'm going to have a lot of fun using this. Watch for it in future projects on my channel. Thank you very much for watching. If you enjoy my videos, consider throwing me some love on Patreon, and I'll see you next time.